Guys, in this video, we're going to talk about different types of angle measures and how you can use them, convert between the different types and everything. So what you guys are probably accustomed to using back in geometry was degrees. You would look at angles and you would say, oh, that's 30 degrees, 40 degrees, 60 degrees, 180 degrees, right? You use that all the time. But degrees are not the only units of measure. In geometry, you should have also studied a different type of measure, but you wouldn't have spent very long talking about it. And this other type of measure is called a radian. And what we're going to do here is talk about what a radian is and how they compare, because in Precalculus, and specifically in AP Precalculus, radians are preferred. All right. When we talk about AP, when you take that AP test, the only type of angle measures are going to be measured in radians. There won't be any that are measured in degrees. So it's really important for us to be able to know how they compare and be able to go back and forth between the different types. We'll talk about other ways to do this as well, but in this video in particular, we're going to focus on the specific unit conversion and how that works, alongside just discovering what radians are and how they're made. Okay? So this is 4.1. You can start your notes page just like we normally do, but you're going to see I don't have anything written here. And the reason for that is because we're going to draw a picture. So if you happen to have a compass, this is going to make it easier. Like a compass like this, where it's got the sharp side and it's got a lead side, so you can make circles. If you don't have something like this, you might be able to be creative, use a piece of string to be able to like swing around with your pencil or something else, or just make the best circle you possibly can. You might find something that you can use to trace and make a really nice circle. That would work too, okay? But what we're going to do first of all is I'm going to find a center point. I want this to be the center of my circle. Now, what I did on mine to still give me room in my notes is I put it maybe 7, 8 lines down on the notebook paper. Doesn't really matter too much. 7 or 8 lines down would be great. A little less would be okay as well. It doesn't have to be a huge circle. It just needs to be big enough, all right? So this would work fine. And what you're going to see is I'm going to put the sharp point of my compass on that point, and then we're going to take the pencil side and we're going to draw ourselves a little circle around that point. So give me a second to get that drawn. I don't always hold the compass the proper way, so my bad. But sometimes it also can make it easier just to turn the paper rather than the compass. Just kind of depends on you. All right. The best we can, get ourselves a little circle. That's the only thing that you're going to that's the only circle you're going to have to draw for today. That's just to give us something to reference, okay? The next thing we're going to do is take something like some kind of straight edge. You can use the edge of a binder or any kind of thing, but we're going to draw a radius on here. And I'm going to get this radius to go on the right side and try to make it horizontal, okay? Remember, a radius goes from the center to the side. It's halfway across your circle, just like that. All right, once you have that drawn, what you'll need to do is get yourself a piece of string, okay? And what we're going to do is we're going to measure this radius here. We're going to cut a piece of string. Mine's got a bunch of lead on it because I've been using it to teach with. But we're going to take this and you're going to measure this little radius, okay? You see that going all the way out? Mine's a little bit long now. My compass must have adjusted some. It's okay. I'm going to just cut off a tiny bit on the end. Okay. See if that's any better. That's about right. Okay, so you're going to cut that to be your radius. You want to get this as precise as possible. The best circle that you can, you want the center to be in the center. And then you want this radius to be cut as close to perfect as you can, okay? That will help this activity go a little bit easier. So we have this little radius on here. Now, the next thing we're going to do is we're going to take our radius and we're going to wrap it around. Okay, so remember how I said there's different ways to represent your angles. We do use degrees a lot in geometry, but degrees are not the only way to represent angles. We have other ones. And so what we're going to study here is a type of measurement called radians. Now, if you hear that word radian and you think, wow, that sounds pretty similar to radius, that's because a radian is made by using the radius, right? So what we did is we created a radius. And what we're going to do is take this radius and we're going to actually wrap it around the circle. Just like that. Okay. So you'll notice we went from where I drew that radius to up here. Okay, that's where that radius ended. And what we're going to do is take your straight edge again, and we are going to connect another radius, right? But it's going to go through this arc that we made. So we're going to try to get that to go as close to there as we can. Again, look at what we did here. We took that string, right? And that string was the length of the radius. We took the radius, we wrapped it around, which means that the length of my radius is the same length as my arc. And when you create an angle by intercepting that arc, where it's the same length as the radius, then this central angle is called 1 radian. We're going to use the Greek letter theta to represent that angle measure. But this angle measure is 1 radian, okay? So I'm going to put another little marking on here. Just like that. All right. Again, what I want you to remember, the length of your radius was the length of my radius, as my arc right there. They matched. And when that happens, then that angle that's formed is 1 radian. Now, keep in mind, 1 radian is not the same size as 1 degree, right? 1 degree is really itty bitty, teeny tiny. But this 1 radian, pretty large, right? All right, we're going to make a little note because I don't think you guys have probably got to use theta very often. Theta is a Greek letter. Okay. Just like that. And we use this to represent angle measures quite often. So we're going to say used to represent angle measures. Okay. So you're going to use that. You're going to see it pretty often nowadays. Big boy and girl math uses theta rather than an x to represent those angle measures. So you're going to see that fairly frequently. Okay. You're going to be good friends with theta by the end of this. All right. So we're not quite done with our little activity. We do have a nice little picture of what a radian looks like. But here's the thing. How does that radian compare to degrees? Now, you could take your protractor, if you have one, and you could sit here and try to guess about how much this is. But my thought is it's not going to be quite perfect. It's going to be a little bit hard to tell exactly what it is. So here's what we're going to do. We're going to do a little discovery. You're going to take your little radius that you made earlier. And remember how we had it wrapped around here? We're going to keep going. Let's pick that up, place it down, and let's mark where this lands, okay? So look here. We pick this up, place it where we left off, and then we mark where that landed. That was another radian, okay? So 1 more radian, but keep going, right? We get over here. Now, I want you to remember halfway around your circle would have been 180 degrees, right? this doesn't quite go halfway. You see, we have 1, 2, 3, and some change, right? So it's a little more than 3. I want you to think about some numbers that we know of that are a little bit more than 3. If you're thinking pi, 3.14, that would be a really good guess, right? Instead of us having 180 degrees, which is what halfway around the circle is, in terms of radians, halfway around your circle is actually pi radians, okay? All right, now if you keep going, we could keep going and we can put some more of these on here, but I want you to think about if half of my circle is 180 degrees, then all the way around my circle to do an entire rotation would be 360 degrees. But what is that as radians? Well, halfway around the circle was pi radians. All the way around the circle would be pi plus pi, 2 pi radians. So 360 degrees or a full rotation, that is the same thing as 2 pi radians. Okay, now that brings us to our actual body of our notes. I know that took a few minutes to get just kind of the basics down, but let's put a formal definition for a radian in your notes. So underneath your circle, underneath all that, we're going to put this guy, some notes, okay? So first you have your definition for a radian. The central angle of a circle measures 1 radian if its intercepted arc length is equal to the radius. Keep in mind, our radius and our arc, both of those were the same length because they were both this little string, right? But I know this is a lot of mathy terms. That angle, when that happens, is considered 1 radian. We have some relationships between radians and degrees. Half a circle is 180 degrees, but that is pi radians. And again, a whole circle, 360 degrees, that's 2 pi radians. We have 2 different ways that we can convert because we could go radians to degrees or degrees to radians. Either way, you're going to use the same relationship because 180 degrees is the same length as 1 radian. So we're going to use that as our conversion factor, 180 degrees over pi radians. If we're going radians to degrees, we want radians on the bottom because we'll want the radians to cancel out. If we're going degrees to radians, we need the reciprocal of that so that the degrees will cancel out. And just as a fun side note, remember that in AP, on that AP test, they will only ever use radians. At least that is what I have been told and what has been hounded into my brain since learning about the AP stuff. Okay, we are talking about both of them in this class because I think long term it's going to benefit everybody to be able to use both of them interchangeably. So I want you to be fluent in both degrees and radians, but the AP test, if you're going to take that test, you will only use radians. They won't use degrees on that. Okay? All right. So this first example, we're going to convert from degrees to radians. All right. So we're going to take this 90 degrees and we're going to convert that to radians. And the way we're going to do it is by using the correct conversion factor. If we want degrees to radians, we're going to use this second one. All right, pi radians over 180 degrees. So we're going to take that and we're going to multiply by our conversion factor. Okay, here we go. 90 degrees, but times pi radians over 180 degrees. Now, y'all may remember from chemistry doing different kinds of unit conversions. This shouldn't be quite as painful as that because we're only doing one conversion rather than a big long string of them. Okay, so this shouldn't be too bad, but important for us to do it. Okay. What's nice here is that this 90 degrees, that's in the numerator of this. You could think of this as 90 over 1, right? So this degree is in the numerator. and the degree on the 180 is in the denominator. They cancel out. That's why we want the 180 degrees on the bottom. Then that actually gives us 90 pi radians over 180. This is technically now in radians, but I want to reduce it as much as possible. So if you look at the 90 over 180, right? 90 over 180, you can divide by 10, and those zeros cancel out, right? If you divide by 10, they go away. The 9 over 18 reduces more because 9 goes into itself once and into 18 twice. So this really and truly reduces down to 1 pi over 2 radians. Now I want you to think about this. 90 degrees is a really common angle to be using, right? Pi over 2 radians is the exact same measurement. It's just represented in radians. So you're going to see pi over 2 radians fairly often as well. All right, let's look at 210 right here. We're going to do the same deal. So we're going to take 210 degrees, but we're going to multiply that by our conversion factor, pi radians over 180 degrees. Remember, the whole reason we wanted degrees on the bottom is so that they cancel and they're gone. So really this leaves me with 210 pi over 180, and this is now in radians. We're going to reduce some more. So you think about dividing by 10, those zeros would cancel. If I divide by 3 on top and bottom, this is going to give me 7 and 6. So really, this is 7 pi over 6 radians. All right, let's look at C. We got 45 degrees. All right, I want you to pause the video, and I want you to try part C and D without me, and then come back and check. Okay, so go ahead and pause the video and try converting this on your own. We're going to multiply by pi radians over 180 degrees. Again, cancel out your degrees. We get 45 pi over 180. This is now in radians, but we still got to reduce it. 45 over 180 reduces because 45 goes into both the top and the bottom numbers. It goes into itself once, and it goes into 180 4 times. So this simplifies to be pi over 4 radians. Fun fact. This is another really common one. I want you to think back to geometry when you did your special triangles. You had your 30, 60, 90 triangles. We had 45, 45, 90 triangles. 45 is a special angle, and it works really nicely in our problems that you're going to see. Okay, so this 45 degree angle, we can think of it as 45 degrees, but in radians, it's pi over 4 radians. All right, one more. I'm going to work out D over here. Try to give us a little bit more room. Scooch this over. Okay. All right, so we take the 150 and we're going to multiply, right? We are multiplying by pi radians over 180 degrees. All right, this is going to clean up. Things start canceling. So degrees cancel. We get 150 pi over 180. This is in radians now. And when you reduce this, we should end up with, what is this? Hold on. 3 goes into both. 5 pi over 6 radians. Okay. All right, guys, last little bit for this video. We're going to talk about going backwards. I know that's really exciting. We're going to go backwards. So we just talked about how do you convert from degrees to radians, but we can also go the opposite direction. And guys, honestly, this opposite direction is actually a lot easier because of the fact that pi is usually in the radians when you convert, and it actually works out very, very nicely. The only difference is we're going to flip your conversion factor, use the reciprocal, because that way the radian part cancels. I also want you to notice another fun thing about this is we don't write the word radian on things that are actually radians. And the reason we don't do that is because of the fact that radians are used so frequently in big boy and big girl math that we don't end up writing it. If it has a degree symbol, we know it's in degrees. But if you don't see anything, if it doesn't say rad, if it doesn't show a degree symbol, if it doesn't tell you what the units are, you automatically will assume it's radians. Okay, so right here you're seeing pi over 3, and I don't see the word rad on here. So, but that doesn't mean anything. I also don't see a degree symbol, which means this is actually in radians already. And we're supposed to convert this over to degrees. So you can add the word radian or rad if you wish, just to visually see how it cancels. But just keep in mind when you don't see it, it is automatically radians. Remember, we're going to flip that fraction for that conversion factor. So radians is going to go on the bottom. And the whole reason for doing that is so that the radian part will cancel out. It's not just the radian part that cancels, though, because we had pi in the numerator on this original one. Pi and radian, they both cancel here. So truly, I'm left with just a 180 degrees divided by 3. And 180 degrees divided by 3 is 60 degrees. All right, next one. We got 3 pi over 4. Same deal. We're going to multiply by our conversion factor, 180 degrees over pi radians. And if you really like to see those radians cancel out, make sure to include that word radian for the original problem. It's just assumed that it's radian because it wasn't written. Pi radians is going to cancel out on both that top and the bottom there. So you are actually left with 3 times 180 degrees divided by 4. And if you work through that, you end up getting 135 degrees. All right, I want you guys to pause the video and try these last two. C says 11 pi over 6. D says 3 pi over 2. So try those for me. Pause the video. Come back when you're ready to go over them. We're going to do the exact same thing as we did on these last two problems. Multiply by your conversion factor. Now, your numbers on this may be a little trickier, but that's okay. Remember, if you like to see that word rad and see it cancel, then write it in there. You can totally do that because it is assumed that they're radians. Those units cancel out, so really we should be multiplying 11 times 180 degrees and dividing that by 6. All right, what I did is I said 6 goes into 180 30 times. 30 times 11 is going to be 330. All right, we got one more. Part D. Part D, we have 3 pi over 2. And again, we're multiplying it by that scale factor. So we should be using that 180 degrees over the pi radians. Again, if you don't like the fact that I'm missing the radians on that first number, include it. That's okay. I know I wrote it really little, but you can do that if you wish. Pi radians will cancel, so those are gone. All right, so really this is 3 times 180 degrees divided by 2. 2 goes into 180, 90 times. 90 times 3 is going to be 270 degrees. Ta-da! Look at that. All right, guys, that is it for this video. That is our introduction into radians and how they compare with degrees. All right. I hope that you feel pretty good about that. There is a practice worksheet that I have included here that you need to do for your assignment on this section to practice converting between these two. I am going to post another video of us talking about one more topic, but you can do your assignment with just seeing what we have covered here. So your assignment just converts between radians and degrees to radians. So that way you can get that practice in. Okay, definitely go check out that, and I will see y'all in the next video. Bye.